calculus lesson on the product and quotient rule. Okay guys, there is a rule that I already wrote out for you. One is a product rule, the other was a quotient rule. So let's say that u and v, or f and g, are differentiable in the defined domain, right? So when you take the derivative of u times v, you write that as u v prime plus v u prime. That's a prime notation or Newtonian notation. Using Leibniz's notation, you could do d dx of f times g. Then, just like before, it's the first times the derivative of the second times the derivative of the first. It's the same thing. In this particular case, I generally tend to prefer this. However, you gotta be careful where you put the prime. If it could be confused as a power of 2 or 3, a power of 1, then I just use ddx, just And this is alternate notation, but I generally, when I was in school myself, we tended to use this notation, and because of that, partially I think, the way I kind of remember this, right, is I just remember a big V shape. See that V right there, guys? The V is right there, here, and here. That's what I see. And I see that U goes in the middle. And I know the denominator is a squared, and we take the derivative of the second of each of the two in the numerator. Okay? So that's me, but I've heard people say, because trying to memorize this could be a little rough if it hasn't been committed to your brain already. So what some people may say is, note that V is the denominator, or G, and U, or the F, is the numerator. That's in the high side, denominator is on the low side, right? So they might say something like a low D high, right, minus high D low. Oopsie. Right. Low D high minus high D low. Me personally, I could never remember that because I never could quite remember low D high minus high D low, or was it high D low minus low D high? So that confused the heck out of me. So I'm a very visual person. So there's a V, V, and a V. To me, I saw the huge V sign over here. So that helped me, but you gotta find your own way to memorize this thing. All right, guys. Why don't we go ahead and try to do the derivative of one of these, right? You know what? Why don't I say that for class? Okay. Yeah, why don't we say that for class? And let's just focus on the lesson, all right? Yeah, so this will be in the class, so just wait. Okay. All right, guys, let's do a couple of examples. I'm going to zoom in just a little bit so you can see better. Okay. Now, we know that this is U, and that right there is a V, right? So one of the ways that you might do this is a U is e to the x, and the U prime, is e to the x, because the derivative of the e to the x is e to the x, right? And the V is as you see it. I just like to just copy it down again. And in the past, when we did the derivative of that was just merely, 1. And then derivative of 5 is 0. And from the past experience, I know that is minus 1 over x squared. Okay? All right. Here we go. So, what do I do at this point? Well, I'm going to write down the formula. Y prime is equal to uv prime plus vu prime. Yes? Okay. Oh, by the way, if you're thinking, wait a minute, I don't remember this over here, right? Here's a quick reminder. You could write that as x to the negative 1, and the derivative of that is you bring the negative 1 to the top, to the front, and you subtract the 1, which gives you negative 2, which is equal to negative 1 over x squared. Got it? All right. Anyways, coming back to this, now that we've done our little work on the side over here, I can just plug it in, right? So what we have, u is e to the x. The v prime is 1 minus 1 over x squared. And the v is x plus 5 plus 1 over x. And u prime is just e to the x, right? So when you see that, I'm going to factor out, notice that the e to the x are both in the front and the back side. So I'm going to just factor that out. And what I'll notice is that I'm just going to copy it all over again as it is, like this. And I notice that these two match, I could add, but these are of varying degree of x to the power of, right? So I like to put it in descending order. So that is y prime therefore is equal to e to the x, and then that is x plus 6 plus 1 over x minus 1 over x squared. All right, guys? So that's the answer. There you go. All right, let's hop on over to the next one. Now, I'm going to show you a slightly different way of writing this out. Some people like to do it this way. So you're going to have a choice. Either do put u and v on the side and just pop it into individual values like this, but I do want to see this way. Or, this is what we do. We know that this is the u, this is the v, and you don't have to do the calculation on the side. You could do it as you go along, right? So I'm okay with this one as well. This is x squared plus 3, and I'm not going to put, oopsie, like this, the prime. That looks like power of 1, right? So in this particular case, when it is kind of confusing, when it's kind of ambiguous, you want to use this notation, right? So remember, we're trying to communicate with each other, so having a clarity of notation is kind of important. Actually, it is very important. And copy the second one as it is, and multiply the derivative of the first, like this. Now, from past experience, now you got to be careful with this one, because now from the past experience, we know that the derivative of negative 1 is, that's right, negative 1 over x squared. And the root x, from past experience, we know that, 1 over 2 root x. Okay? In case you didn't know that, let's take a look. That's x to the half. When you take a d dx of that, half comes to the front, and I subtract 1 over there, that gives you x to the negative 1/2. And that's why you get this. Okay? All right. And then we have, I'm going to write as 1 over x minus root x, and that's going to become 2x. Now, the calculus portion is actually done. That's the easy part. Now comes the algebra. As my professors have always said, it's always the algebra, right? All right, guys. I just want to expand it out. You know how to do it, so I'm not going to talk your ears off as I copy this down. Minus 2x root x. Okay. And then I look at what I could combine. I could combine these two, right? Right. And then that is 1 minus 3 over x squared minus 1/2. I'm going to simplify this one over here. So, oopsie, that's what it gave me. And I notice that these two could be combined right here. So I'll do that. So, hold on, plus 1 minus 3 over 2 root x. The other one is, the reason why I wrote it this way is to write the exponents in a descending order. So that's the power of 3 over 2, power of 0, power of negative half, power of negative 2. Right? So that is the format that is considered in a good form. Okay, guys? All right. So we have one more example that I like to do. Actually, a few more. I lied. Okay, so we have that over here. So we're going to do these three, and then starting from this point on, we're going to do that in class. Okay, guys? So this one is asking us to do what? That's right, quotient rule. So I'm going to zoom in a little bit. There you go. So we know that the u, which is the numerator, is root x. The derivative of that is, from experience, we know this is true. Yeah, you should know that by heart at this point. It is so common. That's the way it should be. Oopsie, that should have been u, my bad. And that is just 1, isn't it? All right, so we're going to write down the form for this formula. V squared v. See that? Makes a v this way, right? Anyways, so vu prime minus uv prime. I'm going to just plug it in. V is 1 plus x. U prime is 1 over 2 root x. Minus the u is root x. V prime is 1 over v prime, which is 1 plus x squared. Yeah, so now the calculus portion is once again done. We're done. But now we're going to do the cleanup. Okay? So that right there is, let's see. Okay. So that's a positive half, negative 1, so that becomes looks like this, right? And then I'm going to clap the denominator. So what that means is that I could put these two in the denominator, right? Common denominator. So that becomes 1 minus x over 2 root x and x plus 1 squared. All right, there you go. All right, sorry I didn't talk too much through the algebra portion. That I expect you to be able to do on your own. And as we do more of it, you sort of learn when to stop or how far to go. And it's something that comes with practice. But I don't want you living like this. All right, clean it up a little bit. All right, as much as you can. All right, guys, let's go to the B. There you go. Yeah, you know what? I favor doing it this way. So it's a lot cleaner. So the u, which is the numerator, is just x plus 1, and u prime is just 1. V is x e to the x, but you know that v prime is going to be a product rule. Yes? Yes, it is. So if you do the other way, it gets really, really, really messy, right? So this, in this case, is the first times the d dx of the second plus the second, oopsie, which is e to the x times d dx of the x, and that should give you x e to the x plus e to the x 1. So if you factor out e to the x, that's x plus 1 like this. Okay? Yeah, it's so much easier. So we got y prime is equal to, once again, I got the big v shape happening over here, right? So that is a v squared, v view of, there you go. Got it? So I'm just going to put this by like this. All right, let's make this wee bit smaller. There you go, I shift it up a little bit. All right, so what do I have over here? V is x e to the x, u prime is 1, u is equal to, oopsie, sorry about that, minus, that is, u is x plus 1, v prime is, ooh, look at that, divided by v prime, v squared, which is, all right, we're done. We're literally done with the calculus portion. That right there, guys, is the calculus, and starting this point is just algebra. That's all it is. And then, yeah, actually, algebra portion is more difficult than the calculus portion. So we got e to the x over here, guys, right? Let's factor that out, and we end up with e to the x minus x plus 1 squared over x. Oopsie, I forgot to square here, guys, right? Yeah, just be really careful. Be careful. And you know that this will cancel here, right? And we need to simplify the top. When you do that, that actually becomes minus x squared plus x plus 1 over x squared times e to the x. That's right. Okay. So this is the minimum work that I expect. For some of you guys, I would expect you to sort of expand that out. And honestly, I got like a nice clean work. Okay. Okie dokie. Now, second question. Ooh, again. This is a wee bit of a work, isn't it? All right. All right. So why don't I do this using the other method, right? Where you actually, instead of working out the derivatives of the numerator and denominator separately, you do it as you go. I just want to demonstrate to you how you would do that. But once again, this is a u, that is a v, right? And the y prime is view of over squared. All right, once again, for me it's a v shape over here, the v here, and a v here. This is the squared apostrophe, the derivatives in the second one of the each grouping of the top. All right, so I'm going to follow that thing, that pattern. So the bottom, as it is, root x minus 1 times the derivative of the top. In this case, I'm going to put an apostrophe here. So that's derivative, right? That's prime minus the top, which is root x plus 1 times the derivative of the second, which is this over here, divided by the denominator squared. All right. And from experience, we've done the derivative of this before, right? We know what that is, which is 1 over 2 root x. Yeah? If you don't remember that, once again, ddx of the root x equal to ddx of x to the half. We bring the half to the front, subtract 1 over here. That's 1 over x to the negative half, which is equal to 1 over 2 root x. Got it, guys? All right. So when we do that, we're going to copy that one over again, and that one gives you 1 over 2 root x. Derivative of the 1 is 0. And this over here is, once again, we're going to get the same thing. And these two, because they're in the denominator, we could just bring it down to the bottom, can't we? Right? So when we do that, it is root x minus 1 minus root x plus 1 over 2 root x times root x minus 1 squared, and they cancel. So that is 2 root x minus 1 squared. Yeah, the calculator portion was done here. From here to here, there's only one step. You just have to, this is all thinking part, right? You should be thinking about all this, but in reality, there's only one step that's calculus. The rest was just manipulating the expression, right? All right, guys, so I'm going to put all the calculus portion on the same, oopsie, no, I don't want to do that. On the same line, right here. And the rest is over here. And I'm going to be a good student and make my teacher happy. Therefore, make it very clear what the answer is going to be, and we're all good to go. And I'm going to indicate that's my answer. Yeah, you could either say therefore or line or even a box will be fine. Okay. Okay, there you go, guys. That is a note, and we will pick up your turn over here, right? And then we will do one more page after this. Okay. All right, guys. That is today's lesson. All right. Have a good night, guys. I'll see you tomorrow.